The level of power quality disturbance will set a limits to the amount of distributed generation, so that can be connected to the power system. The power quality can be a local issue like high disturbance due to one or few generators, or the global issues like resonance or the weakening of this transmission grid. The power quality sets a limit, so there are the number of measures that can be taken over to allow more distributed generation to be connected. So that is to increase the hosting capacity. A number of these measures will be discussed in this session. Among that, first is the strengthening of the grid. With the power quality disturbance, the voltage disturbance level is often proportional to this source impedance at the location of the source of disturbance. For example, voltage fluctuation or voltage flicker, the rapid voltage change, and the unbalance. For all these disturbances, it is the impedance of the power system frequency that matters. Increasing the fault level will reduce the voltage disturbance level. Also for harmonics, the source impedance impacts this voltage distortion in some way, but the frequency depends upon the source of impedance. That makes the situation more complicated, or it is an harmonics issue. Increase in the fault level may increase or decrease the harmonic distortion depending upon the frequency. For low order harmonics, strengthening the source will in almost all the cases will reduce this voltage distortion. For higher order harmonics, no general conclusion can be drawn. So there are various way of strengthening the grid, like adding lines or cables, adding transformers, reducing the feeder length, and increasing the feeder cross sections. These have traditionally been an important tool in the design of distribution and the transmission system. It has become very difficult, however, to build a new line, especially at higher voltage level. So as a result, other situations are more and more being discussed in this concern. An additional reason why strengthening the grid is not always considered as a first option. So to do with this fact, the multiple stakeholders are involved in the power quality. The network operators have a duty to maintain at an acceptable level for a power quality. To ensure this, they place a limit on the transmission by these individual customers with standard settings organizations like IEC and IEEE. Emission limits for individual customers and devices are defined. It is considered that the emission by the devices are by individual customers in such that a well designed grid, so the voltage disturbance level do not exceed the acceptable level. It is considered that emission by the devices or individual customers is such that in a well designed grid the voltage disturbance level do not exceed the acceptable level. Although there are a number of problems with this approach, such that what is a well designed grid? Although there are a number of problems with this approach, such that this approach is generally used for network operators as well as during the development of this new standard. The result is that strengthening the dips, the situation becomes more complicated. So with this we have seen the some effect of this strengthening grid. So the overall conclusion is for a power quality events such as voltage dip and voltage dip. So with increase in the grid, so the hosting capacity will become more and more complicated. So this is about the strengthening of grid. So now let us see the emission limits for the generator unit. The phenomena discussed in the previous sections like overloading, losses and voltage rises are related to the transport of this active power by new generator units. So it is difficult to imagine a generator unit that does not result in any change in the active power transport. Setting a limits on this active power transport would immediately put a limit on the size of generator. With several of the power quality disturbances, the situation is different. For example, setting a limit on a amount of harmonics that can be emitted does not directly limit the size of the unit. It might only make the unit more expensive because the different grid interface could be required here. And also the situation will become more complicated for an unbalanced due to large number of the single phase generators. For a slow voltage fluctuation for a time scale for several seconds or even longer for high frequency distortion. Reducing unbalance due to single phase generator would require a limit on the size of the number of these generators units. So reducing slower voltage fluctuation would require some large energy storage. Also there are not yet suitable performance indices for slow voltage fluctuation. Such indices and associated limit for acceptable levels are needed for before emission limits. So this can be placed on individual generator unit. The same holds for high frequency distortion. The setting limits on the emission by the individual generator units will not help against the weakening of transmission system or against the harmonic resonance. So here the such indices which are associated to the limits of what the acceptable levels are needed before emission limits can be placed on individual generator unit. The same holds good for high frequency distortion also. The setting limits of this emission by the individual generator units will not help against the weakening of transmission systems or against the harmonic resonance. This is about the emission limits on the generator unit, the emission limits for generator unit. So let us see the emission limits for other customers. The emission by distributed generation is in general small. However, it does result in overall increase in the level of voltage disturbance. So this could be a problem locally when a large generator unit is connected to a location with a large disturbance level. A further increase is to be expected from weakening of the transmission system and from the harmonic resonance. When the acceptable levels are not changed, so this increases simply which leaves a less space available for new customers. The rules for allocating this emission limits to an individual customers are discussed in our number of documents. The most widespread ones are those three technical report issued by IEC, but several countries and even individual network operators having their own rules. A common approach is to choose a level that is seen as a highest acceptable level after the connection of new customers. This is called as planning level. Next planning level is compared with existing level, that is before the connection of new customers. The difference between the existing level and planning level is a permitted increase due to new customers. Using some kind of allocation algorithm, so this emission limit in terms of the voltage is the next planning level. Unchanged will result in the reduced emission allocation for a new customers. So this new customers may actually be a distributed generator or a wind park. When the existing level becomes more close to the planning level or even exceeds the planning level, so the connecting new installation could become difficult and it is expensive.